Hello everyone, so in this video, let's talk about the minimum moves to equal array element part 2. I already made a video on part 1, so go check it out as well. So you are given an integer array nums of size n. Return the minimum number of moves required to make all the array elements equal. So in one move, you can either increment or decrement an element of the array by 1. So you are given some array as you can see here. You can either increment the value of the array by 1 or decrement the value of an array by 1, like any element of that array. And you have to make all the elements in the array equal in as minimum number of moves as possible. That is our overall problem. Now, how can you approach it? Because you can increment some values and you can decrement some values. It's better that we have to decrement the larger values and increment the smaller values. So if we have some values, there's some larger values, so I can decrement the larger values and we can increment the smaller values to some sort of a middle point. What the middle point? You can sort the array and you can get the middle element, and then whatever element are on the left hand side to the middle element, make it smaller, equal to the middle element, which are on the right hand side, make it smaller, and on the left hand side make it larger. Okay, that's the overall problem that we are going to solve. Nothing much complicated itself. I've just sorted the array, then find out the middle element, answer to store the number of moves that we required, then just do a for loop, and then just find out the absolute difference between the middle element and the nums of I. You can do two for loops as well, from left to the middle and middle to the right, or else you just have to find out the absolute difference. Absolute difference is that I want to reach here, the middle element value. If it is smaller, I want to increment it. If it is larger, I want to decrement it. So you can directly just get it using the absolute value, and you can just print out the answer. Okay, that's the only logic, nothing much. It's just O of n log n in sorting. Okay, and then you can say this elements is absolute value. Now, as you can see, you have to find the middle element. So obviously you have to sort it out so that you can get the middle element of there. So that is required, and then this is O of log n, O of n. Complete angle velocity is O of n log n. That's the